3 times. So that's 2 times itself 3 times. Right here. And then you have 2 to the 5th, which is 2 times itself 5 times. So if you have 5 times and 3 times multiplied together, how many times do you multiply 2 by itself? 8 times. What this means is, if you have the same base, a to the m times a to the n, what does that equal? A to the... You add. Exactly. You have to have the same base. So you'll see that right there. You need to have the same base. Super important, because if you don't have the same base, the rule does not apply. So what do people do sometimes? They add the powers even if the base isn't the same. Can you do that? No, you can't. So what happens if you had 3 to the 4th times 3 to the 7th? What does that equal, Aubrey? 3 to the...
Am I adding?
Yep. Yeah, done. Nice. What about this one right here? What's 5 to the 3rd times 5? 5 to the 4th. Because what's the power of that blue 5 in there? Just 1. What about here? 5 times... Yeah, well, you can, because what's 5 times 3? 5 times negative 3. It's negative 15. But then what's y squared times y to the 4th? Y to the... There it is. Negative 15y to the 6th. What about f, though? Can you do anything with f? Is there anything you can do with f? No, because they don't not the same base. Not the same base. It's not the same base. You're done. You can't go any further. Another thing, another common mistake is you guys will crank through a simplification. You'll be done, but then you'll think maybe I'm not done and need to keep going, and then you make something up. Like if you got to x squared times y, there's nothing else you can do to that realistically that makes it any nicer. But some people write it's xy to the 6th. Is that true? No. You can't add bases. You can add exponents if the base. What about this right here? This is just something that's true, and we don't really prove it in this class, but I can show you some graphs later. Anything to the 0 power is 1. Anything to the 0 power is 1. We're not going to prove it right now, except for what number? Yeah, a doesn't equal 0. 0 to the 0 is said to be indeterminate. Yep. You see it all the time in calculus, but if you 0 to the 0, if you can say it's not defined. But anything else to the 0 power, anything else to the 0 power is equal to 1. Is equal to 1. 78 billion times 70, all to the 0 power, that equals pi to the 0 power, 1. Anything that isn't 0 raised to the 0 power is 1. A table raised to the 0 power is 1. How many people have dealt with negative exponents before? Negative exponents. This is essentially all you need to remember about negative exponents. There are some shortcuts that you will learn, but this is the core to what it means to work with a negative exponent. A to the negative n power is 1 over a to the n. You have now eliminated the negative exponent. You have now eliminated the negative exponent. The challenge comes in the weird phobia that's not really based in any sort of reality that you all have with negative exponents. So you're going to practice some pretty straightforward ones to begin with here. Please this out. So I think this is going to be 1 over 8. This is going to be 1 over 6. Negative 1 over m squared. 1 over m squared. What about a right there? What's a going to be? Anybody have a? What is a? 8. Correct. It is 8. And can anybody tell me what b is going to be? Anybody tell me what b is going to be? What? 9 over what? Correct. Which one would you like to talk about, kids? Which one would you like to talk about? Because that's equal to, what does the negative exponent mean? 1 over negative m squared. That's 1 over negative m times negative m. What's a negative times a negative? A positive. That's why the negative goes away. What about a right here, the second a? What does 2 to the negative 3 mean, Liv? What does it mean?
It means 1
over 8. Dividing by a fraction is this. Dividing by something is multiplying by the reciprocal. So that's equal to 1 times what? 8 over 1, which is 8. Ah, okay. What about this one right here? How did we get 9/8? What is 2 to the negative 3? 1 over 8. What's 3 to the negative 2? 1 over 9. Dividing is the same thing as multiplying by what? So that's 1/8 times 9 over 1, which is 9/8. There it is. It just takes practice, everybody. It just takes. So a to the m over a to the n, what's that going to be equal to? Yeah, you subtract. Absolutely. Very good. So try this for me. Simplify these four for me. You're just subtracting. You're just subtracting. So try. So I think this one was a 3 to the 7 minus 2. What is that equal to? 3 to the. So this is 2 to the 7 minus what? So it's 2 to the. This is 8 to the negative 2 minus 5. So that's 8 to the. Which is 1 over 8 to the 7. Final answers. And then what about this one? This is z to the negative 5 minus negative 8. What does that come out to be? Z to the third. Here are your answers right there. All you did was subtract. Just be careful. You have to bring that 3 in all places. Okay, by yourself, try simplifying. You distribute it. So it's 4 to the what? X to the 5 to the. So here's the thing. We've distributed, but are we done? We're not done because we still have negative exponents. What do the negative exponents mean? 1 over 4 to the 1 over 1 over. And we know that, what does this equal? The top, right? You can take the top. It's the numerator times the what of the denominator. The numerator times the what of the denominator. The reciprocal. What's the reciprocal of 1 over 5 to the third? Over. So what does the final answer come out to? 5 to the third over third x cubed. You can leave it like that. That's fine. Does that look like something we just had? Look where we started and look where we ended up. What happened? What happened?
You just flipped it.
It's swapped.
When you have it all, when it's all multiplication, you can do this. You can flip the side, go from numerator to denominator, and just flip the sign of the power. So 5 to the negative 3 is down below. Where can you put it? But make it positive. And if the negatives are here, you bring the whole thing down and make them positive. Anytime you move sides, it'll flip the sign of the power. It'll flip the sign of the power. They call this a special rule, but this is just a result of math. So what this means is, what's a to the negative m over a to the negative n equal to? Or b. We can say b. Sorry, b. What's that equal to? B to the n over a to the. You need to put the to the in your phrasing because am means a times m. A to the m means something entirely different. Entirely different. Okay, so you don't have the same base. But what did I tell you before? What does 6 equal, Milo?
6 equals.
What's another way to write 6? 2 times? 2 times 3. What do you do with that fifth power?
You distribute.
What are the invisible powers? Oh, it's 1 and 1, so it becomes 2 to the 3 to the all over. Do I now have a common base? So what does that equal? 2 to the what power? 2 to the second, 3 to the.
Is that actually considered cleaner than?
2 to the second, 3 to the fifth?
That's simpler than.
Well, it's all relative, right? I mean, it's simpler in the fact that it doesn't have a division symbol in it. Generally speaking, getting rid of the division symbol is preferable. You've reduced that as far as it could go. That's like that's the most reduced form of that fraction. Anything's a fraction, but that one's over 1. But yeah, you bring up the interesting point. Distribute it. So it's negative 4 to the negative 2, m to the n to the
Negative 8.
all over 24 to the negative 2, m to the and n to the. So here's the thing. You look at the 14. Thank you. That's important. Yes. There's a common mistake. Not forget the negative. Now you break it down into small pieces. Don't try to do everything at once. So for example, let's just leave these numbers alone. What did I tell you can do with those negative exponents if you wanted to? Well, let's just do it Let's just do it the more generic way first, and then we'll look at shortcuts. First of all, you have 3 fractions essentially. You have this, and then what else do you have? M to the over m to the negative 2. All I'm doing is regrouping. Am I allowed to do this?
Yes.
What do you do with exponents if you have a common base? Subtract. Do we have the same base?
No.
No, so let's ignore that one for now. Let's look at this one. It's m to the negative 10 minus what?
2.
No,
Negative 2.
negative 2. N to the negative 8 minus 14. All you're doing is subtracting right now, and I'm keeping this the same for now. Negative 4 to the negative 2, 24 to the negative 2. What's negative 10 minus negative 2?
1 over.
No. Answer the question that I am asking. It will help you, me, and everybody else be awesome at life.
This is -8.
Again, not the answer to the question I asked. What is negative 10 minus negative 2?
-8.
That's the answer I wanted. M to the negative 8. What's negative 8 minus 14? Negative 22. Do you understand why I fundamentally don't like it when people answer straight? It's not that I don't like it. It's just that if you did the same thing in English class, if you did the same thing in social studies class, it doesn't work. It's like, what's the capital of Oman? And the world. You know, just be more specific. Be more specific. I like that the enthusiasm, you're going to the answer, but I want to break it down into the small pieces. Okay, so what does this mean we have now? We have negative 4 to the negative 2, m to the negative 8, n to the negative 22, all over what? 24 to the negative 2. Are we done yet? Why? What do we not like in there? We don't like the negative exponents, right? What can you do with this right here? Where can you put it? And what can you do with this? So what does this become? Oh, what is negative 4 times negative 4? Okay, but let's just do what I said first and not try to do too much. You have this, 24 to the negative 2, and now we have m to the 8, n to the... Are we getting closer?
Why can you drop that down?
You can. I'm just telling you you can, okay? We talked about it a minute ago. Because if you have a negative exponent on top, you can bring it to the bottom and make it positive. You can. So what can we do with what can we do with these right here? It can be 24 squared over negative 4 squared m to the 8 n to the 22. You can flip this if it's on the top or the bottom, but what do you do with the exponent if you move it from top to bottom or bottom to top? Switch the sign. So if this goes down, it has to become a positive 2. If this goes up, it has to become a positive 2. You can simplify this a little bit if you wanted to. But do we have all positive exponents? Yes. If you wrote this, you would get totally full credit right there. Totally full credit.